Hello everyone, this is our next video of IP Sec VPN series, and today video we are going to discuss phase 2 exchange. So we already covered the phase 1 and the main mode, aggressive mode. So if you have not watched the previous video, so I suggest you just first watch the previous videos, then you can proceed with this video. So let's begin with the today topic discussion. So phase 2 exchange. The purpose of phase 2 is to stabilize the SA for the actual IP connection. So this is the main purpose. In the phase 1, the actual connection was not stabilized. The actual connection will be stabilized in the phase 2 only. The SA is referred as the IP Sec SA. So after negotiation between two peers, we got the SA, and those phase 2 SA we called as a IPsec SA. This means that IPsec connection between two systems require two security associations. So yes, so it means that we have a two associations. For one is for phase 1 and second is for the phase 2, and the phase 2 association we referred as a IPsec SA. The pair of IPsec SA is created through a single mode. So there is a one mode in the phase 2. That mode is called as a quick mode. So in the phase 1 we have a two modes, main mode and aggressive, but in the phase 2 we have a one mode. That mode we called known as a quick mode. Quick mode uses three messages to stabilize the SA. So in the phase 2 we have a three messages that is used to stabilize the SA for phase 2. Remember that quick mode communications are encrypted by the method specified in IKE SA created by phase 1. So this is very important point, that phase 2 all communication is encrypted because we have already built the phase 1 tunnel, and this phase 2 traffic is going within a phase 1 tunnel. So let's begin with the other discussions. So what are the three packets in the phase 2? In the first message, endpoint A send a keys, nonce and IPsec SA parameter suggestions. So nonce means this is the randomized data that is sent by the VPN devices. The nonce are an anti-reply measures. In the second message, endpoint B send keys, unknowns and IPsec SA parameters selected plus hash for the authentications. So in the first message, endpoint A sends the details of the SA parameter. In the second message, endpoint B sends the keys for the parameters, and in the third message, endpoint A send a hash for the authentication. So in this packet, already endpoint B has performed the authentication, and in the third message endpoint A will perform the authentication. So between these exchanges, phase 2 connection will be stabilized. So this is the one data capture which I have taken. So we can see that ISACM 500 is used as a source and ISACM 500 is used for the destination. So what is ISACM? We will discuss in the next videos. And this is the Internet Security Association Key Management Protocol. So this is the full form of the ISACM. We can see that they are using quick mode as a negotiations, and these are the initiator cookie and responder cookie. And now encrypted, no commit and no authentication. So these are the packet for phase 2. So I have a one diagram for phase 2. So we already discussed that first in the IPsec they will create a phase 1. So this is the phase 1 tunnel. In the phase 1 tunnel, the actual transaction will be happen. So this will be the happen on this way. The actual transaction is on this. So two SA pair will generated, one for incoming and second for the outgoing. And see, this is for the phase 2 IPsec SA and this is for the phase 2 IPsec SA, and this whole communication is running in the phase 1. So we have a one tunnel. This is our one tunnel, that we known as a phase 1, and in the phase 1 there is another tunnel is running, that is the phase 2, which is responsible for actual data support or actual data flow communication. So let's move forward. So this is the another packet I've taken, where this is the initiator and this is the responder. They are in the quick mode, so they will send the first quick mode. This is the packet 1 or message 1. They will send the hash value, proxy ID. Proxy ID means that the interesting traffic, local LAN addresses of the both side, we known as that interesting traffic. SA and SPI parameter. Then responder will send that hash nonce proxy ID and SA and perform the authentication. This message will send to the initiator, and initiator will again acknowledge the hash. If hash matches, authentication matches, then this tunnel will stabilize and phase 2 will work. So let's see, move forward. So this is the another, after B validates the third message, the IPsec SAR stabilize, all active SA is stored in the security association database. So this is the things they will negotiate, that source IP address, SPI, mode, tunnel or transport, encryption, integrity, security, key exchange, key length. This all thing we negotiated during these transactions. So other things will also negotiated, that as a lifetime sequence number, anti-reply information. So this will be negotiated. So another thing is the information key exchange. This is also used in the IKE transactions. The purpose of IKE informational exchange is to provide the endpoint way to send each other status and error message. The IKE SA provides the protection for the status and error information. So the use of IKE information exchange, it is used to provide the status and error message between the transaction, or we can say that between the communication. We can also say that between the message exchange. So this is the major responsibility of the informational exchange. So we can, and ensuring that unauthorized message do not disrupt. So means that any unauthorized message will not disrupt this communication. Let's say one example I've taken. One endpoint tell, here endpoint means that the VPN device can tell another endpoint that particular SA should no longer be used. So here this is the two, and this is will be the two endpoints. So this means that VPN gateway, and one VPN device is sending a message to the second VPN device. So what will be the message? One endpoint can tell another endpoint to that particular SA should no longer be used. So one SA not in use. However, the message sent through the informational exchange are UDP based. The recipient does not acknowledge them, so there is no guarantee that other endpoint will receive them. So due to this message are in UDP, so there is no guarantee that other will be responded. So there is the group exchange. This is also used, but currently not in commonly used. But this I have taken for the general information purpose only, and this is not in used commonly. So each group number specify a modular size and encryption generating type. So we already discussed that during the negotiation we exchange the key, we exchange the Diffie-Hellman group. So using that Diffie-Hellman group, they will generate a key. So those process we known as the encryption generator type. The IK group exchange can be used to negotiate the creation of additional Diffie-Hellman's group once two endpoints agree on the characteristic of the new Diffie-Hellman group. They can specify its number in the future phase negotiation. Diffie-Hellman's defining a new Diffie-Hellman groups is not a trivial matter. Because of why this is not used, because let's say we have already defined the DH key on the both sides, that group side. So this was used to generate a keys, but we already defined during the IPsec creation process. There is no meaning to define a new DH key during this IK phase 2 creation process. That's the reason this is not used group exchange commonly. I have taken this because of the additional information knowledge. So there is another version of IKE we known as IKE version 2. So I have taken the major differences that we have on the IKE version 1 versus IKE version 2. So what is the differences? IKE version 1 less efficient, less efficient in stabilizing the secure connection. However, IKE v2 more efficient, faster setup secure VPN connection. Limited support for the modern encryption and authentication methods. Support advanced encryption algorithms like AES and use EAP for the authentication. So IKE v2 supports a latest algorithms plus authentication which is not supported by IKE v2. Does not support the PFS. So IKE v1 does not support the PFS, but IKE v2 supports the PFS, enhance the security for session keys. And also instability with the network changes, improved stability handling network changes and interrupting network. So this is the more relevant, more efficient as compared to that IKE v1. So let's move on the one more difference about it. Designed for the less dynamic network environments and optimized for the modern dynamic internet use and support seamless network transactions. So this was the major difference between the IKE v1 and IKE v2. So now nowadays mostly all organizations have shifted to IKE v2 because of the latest algorithms and the fast transactions in the VPN. So no, even still most of the organization are v1, but other organizations have already shifted to that v2. So the purpose of the differentiation between IKE v1 and IKE v2, so many of the interviewer they ask during the interviews that what is the difference between the IKE v1 IKE v2. So I have covered in this video. So for this video I have covered till the whole VPN creation process. I hope you enjoyed this video. Please don't forget to like and subscribe the Firewall Experts. Thanks for watching.